हेलो एमएससी, वेलकम बैक टू माय चैनल। तो आज का हमारा जो वीडियो लेक्चर रहने वाला है वो एलिफेटिक न्यूक्लियोफिलिक सब्स्टिट्यूशन की यूनिट के अंडर ये टॉपिक SN1 मैकेनिज़्म है। सो इट इज़ अ यूनिमोलिक्यूलर न्यूक्लियोफिलिक सब्स्टिट्यूशन मैकेनिज़्म. It follows first order kinetics, means rate depends on the concentration of one reactant, and that is substrate. It is a two-step reaction, means first step is rate determining step, that is slowest step, and second is the intermediate carbocation when combined with the nucleophile to give the desired product. And next, rate depends on the concentration of alkyl halide only, so nature of the nucleophile doesn't affect the rate of the reaction. And then stereochemistry racemic mixtures are formed. And then reactivity of alkyl halide is in the order 3 degree, carbocation is more stable, then secondary, then primary. In this example we see in first step, which is the rate determining step, slowest step, means slow heterolysis of the substrate to give an intermediate carbocation. Tert butyl bromide is converted to tert butyl carbocation, which is a very slowest step. And second step is the fast combination of the intermediate carbocation with the nucleophile, means it is a fast step and gives the substituted product. Next we see the evidences for SN1 mechanism. Its first is its kinetics. SN1 is the first order reaction, means rate depends on only the concentration of the substrate. Rate depends on substrate, means rate is equal to K and the substrate. Next is stereochemistry. SN1 reaction proceed with the partial racemization and some inversion, means in actual way the complete racemization occurs very slowly and rarely, means approximately 5 to 20% inversion occurs, means attack of the nucleophile occurs before the leaving group departs. Thus leaving group shield the front side of the carbocation from the attack to certain extent, thereby facilitating the attack from the back side, resulting in the inversion of the configuration. Then more stable carbocation. If there is more stable carbocation, then greater racemization takes place. Therefore, in such cases, the leaving group gets time to leave before the nucleophile attacks. So leaving groups leaves and then the nucleophile attacks. Thus, equal possibility of the attack from either side of the carbocation, giving rise to the racemic mixture. And then less stable carbocation, means if there is less stable carbocation, then inversion and less racemization takes place. Therefore the nucleophile attacks before the leaving group departs. Departs means leaves, which blocks the front side, and thus back side attack occurs, giving rise to the inverted product. We can explain this with an example. Solvaces of optically active 1-phenyl ethyl chloride leads to 98% racemic mixture as it forms the stable benzyl carbocation, while 2-octyl chloride give only 34% racemic mixture and no stable carbocation is involved. So in first, means 1-phenyl ethyl chloride, we have taken the example. First step is the slowest step, in which the equal attack of the nucleophile takes place from both the sides, and then in second step, which is a fast step, give retention and inversion takes place, which combine to give a racemic mixture, means the product is the racemic mixture. Then next is, in case of solvaces, more nucleophilic the solvent, the greater is the proportion of inversion, means fast attack from the backside by the solvent which is nucleophile, as front side is shielded by the leaving group. For example, the solvences of 1-phenyl ethyl chloride in the mixture of 80% acetone and 20% water gives 98% racemization, but in more nucleophilic solvent we take a water which is in pure form, only 80% racemization takes place, means greater proportion of inversion occurs. Now stereochemistry of SN1 reaction can also be discussed by the ion pair. Now we take this Rx, means original substrate, give 1, means R positive X negative, which is intermediate or tight ion pair, then loose or solvent separated ion pair, and then is dissociated ions. Original substrate and intimate or tight ion pair recombine to give the internal return. Now nucleophile can attack at any stage, and the product from the ion pair rather than the carbocation. Now first, if we take first intimate or tight ion pair leads to inversion, as the attack takes place from the back side, as the front side is shielded by X negative, means any nucleophile. Second is more likely lead to racemization, as the backside attack takes place. And in third, equally from both the side attack takes place, means racemization increases. So from step 1 to step 3, degree of racemization increases and the proportion of inversion decreases, and the stability of R positive increases and the power of attacking nucleophile decreases. The proportion of 3 increases. And next evidence is formation of the rearranged product. As the reaction proceeds through the carbocation, then the rearrangement is very important characteristic of the carbocation, and thus more than one product is formed in SN1. As from this example, we get the normal product and the rearranged product. Next evidence is no substitution at the bridgehead carbon. SN1 reaction fails at the bridgehead position. So SN1 reaction involves the carbocation, which is the planar. And from this example where the chlorine is attached at the bridgehead, so by putting KOH, ETOH and reflux it at 21 hours, no reaction takes place at the bridgehead carbon, means no substitution takes place at the bridgehead carbon. Okay, thank you.